thank you for joining us this morning for another What's New series of webcasts for SOLIDWORKS 2011 What's New. My name is Enrique Garcia with Digital Dimensions. This morning we're going to be talking about simulation and motion studies. So this will be a hit list of all the topics we're going to be covering. We'll be covering simulation and motion this morning. Not too much extra added on to motion, just a little something called a function builder, which allows us to go in and enter information a little bit easier. The interface has slightly changed in regards to that, so we will be talking about that in motion. For simulation, something huge which I'm glad was brought up this particular release was the ability to do a quick, easy way of simplifying your geometries in 2 dimensions. We typically go in and we do this automatically. We will either cut off a section or a pie shape for a cylindrical turned part, and we'll add some constraints to it, which will simplify our models. SOLIDWORKS has done something very similar and more convenient at the initiation of the study, which we'll go ahead and go through this morning. Also, some other things I want to talk about will be the ability to go in and look at some of the interface changes. There have been some slight little tweaking of the interfaces, which I think is nice and enhances the usability and the feedback you get on your screen. Also, some other enhancements are the nonlinear fixtures, which we have improved accuracy when it comes to some nonlinear studies, and also it goes and converges the study a little bit quicker, I heard. Also, we'll talk about some mesh enhancements. Let's go ahead and get started. Let's go in and jump in, and let's talk about 2D simplification. So two-dimensional simplification, again, said that we can simply take 3D models and convert them to a 2-dimensional cross-section. Now, there are 4 approaches to going and doing this process. The first process is called plane stress, and let me show you the interface of how to approach the 2-dimension functionality in simulation. Let's go in and start a new study. Let's say I want to do a nonlinear study. Let's say for this particular model, we've taken this and we're going to do let's do 2D simplification. When I click OK there, you'll see a new little interface. So this is my portion of a bolt and a nut. Now we've taken the thread and we've simplified the thread. This is going to be our assumption. We're going to be figuring out the stress and strain as a result of this nut acting on the thread. So for this, we're going to go in and just simplify our thread and not make it a helical path. It'll make our study a little bit quicker to resolve. Now, if you look at the very top of my property manager, we have 3 different approaches. We can take the plane stress approach, which is actually meant for thin models, whereas you're not interested in, or there will be no force acting normal to my section plane. Also, we have the plane strain function or ability, and this is actually meant for models that have thick geometries that extend along the distance of either side of the section plane with no force, again, acting normal to that section plane. And lastly, we have another one that's not actually included here, which is only for thermal studies, and this is called the extruded bullet that typically shows up in this area. And this simulates geometries with constant thermal loads along the extrusion direction. And again, this option is only available for thermal studies. And the one we're going to be working with this morning is the axis symmetric option. Now this enables us to take, simulates geometries, material properties, loads, and fixtures that are symmetric about an axis, in this case about this natural axis of that shank for the bolt. This would typically be done in an early release if you take a pie cut of this and take 1/4 of it, 1/8 of this particular model, and add some advanced constraints and perform your functions in that regard. So we're going to do axis symmetric, and I'm going to choose a plane. I'm going to choose this plane there and an axis. We'll get a little preview. You can see a little yellow preview, similar to a dynamic preview in SOLIDWORKS. I'm going to click OK. Now you're left with this cross-section. So let's go and do a quick study on this cross-section. I'm going to go in and do some setup here. I'm going to do, this is a nonlinear study, so I'm going to go to my properties, and we're going to assume a large strain option and a direct sparse, since our mesh size is very low, so we want to optimize that. I'm going to go in and choose a model for my material. I'm going to choose the default alloy steel, and for my model type I'm going to choose a plasticity von Mises. And let's go ahead and add a contact set here. Let's go choose a no penetration contact set amongst the shank of the bolt and my nut. Also under advanced, we're going to go ahead and choose surface to surface just to again quickly converge the study. Let's go and add some fixtures on this. Let's do a roller slider fixture. We're going to be allowing movement along the x-axis. So let me select that edge. Now again, when you're doing 2D simplification, it's important to pick edges and not surfaces. And let me go and choose my nut. Do a roller slider condition there. Now let's apply a load. Let's go and do a, how about a 3,000 pound force on the top of the shank there. So let's select that top edge. Let's choose my plane. Plane 1 will be adequate. And let's choose 3,000 pounds, foot-pounds, 3,000 pound force. We're going in the positive Y direction. And let's go ahead and solve this study. Let's do a quick mesh here just to take a look at the mesh. This is great. This allows us to be able to use more resources with a less amount of time, calculation time. We can definitely go in and we can refine this mesh like mad and get a really good answer with this 2D simplification. At that point, I can go in and maybe do a 3D study if I would like later on, just to compare. But this does a real good job. Let's go ahead and run this study. Nothing has really changed with my study windows. We get some nice good information, degrees of freedom, number of nodes and number of elements, all real good information. Alright, so there are my result plots, and again the same standard result plots appear that you set up inside of your simulation options. Now you may be looking at this and noticing that we're working off of a 2D model, and for us as engineers this is great, right? We can just take a look at it, we know what's going on, but if you're presenting this to someone else, you maybe want to show this in a 3D fashion. So they've added a functionality. If I go into the stress plot and I right click and select show as 3D plot. And now what this does is this enables us to, it basically interpolates and revolves that same cross section 360 degrees. And actually you can change that, and let me go ahead and change this so we can see it on the inside of the model, and so I can see the results a little more clearly. I can go and edit the definition of that plot. Under advanced options we have this new little interface change where I can change my revolve there. Let's do 270, and this will update my graphics area so we can see inside of the model and on the outside. Alright, I want to go in and I want to show a new type of study that we have, and this is going to be for our dynamic analysis studies. This is available in the Simulation Premium package. We have a new tool called the Response Spectrum Analysis Study. Now, a response spectrum analysis takes the results of a model analysis and are used in terms of known spectrum to calculate displacements and stresses in the model. For each mode, we have a response is read from a design spectrum based on the modal frequency and a given dampening ratio. So all of these modal responses are then combined to give us an estimate of the maximum response of a structure. And what this is good for, let's go to go in and instead of using time-dependent loading studies, we can go in and we can we can actually simulate what would happen for our design during an earthquake, wind loads, ocean wave loads, jet engine thrust, or actual rocket motor vibrations. So let me open up a model here. Let's take a look at this new type of study inside of dynamic studies. So I'm going to take this model here of this circuit board, and I'm going to start a new dynamic study. If I go down here to linear dynamic, I used to have 3 options, and now I have this extra one here, my response spectrum analysis. I can select that, and I can start a new study. So I basically want to go in there and add all my different constraints, my boundary conditions, my assumptions, my study properties. I've already done that, and in addition to that, I added a uniform basic citation there under my external loads. Let's go ahead and take a look at that if you'd like. It's a simple one gravitational unit along the plane in an acceleration type of basic citation. So let's take a look at my results here. So I went ahead and ran that study. It doesn't take too long to run. And let's go ahead and show my stress won't have anything. My displacement plot is something I want to show. Notice my deformation scale there. Now, there are different ways of calculating this particular type of analysis. Let me go into my study properties here. So it will depend upon your application, and that will take just some knowledge on your part. If I go into my study properties, I go to response spectrum options. I have 4 different ways of, or 4 different flavors of calculating this particular model. I have, which I would probably recommend as maybe for a very initial study, I would use the absolute sum. This seems to be the more conservative among all the modal combination methods. We also have this next one, the absolute sum, which estimates the peak response by the square root of the sum of the maximum modal responses squared. And then we have another one, we have the complete quadratic combination, which is based on random vibration theories here. And then lastly, we have the Naval Research Laboratory technique, which takes an absolute value of the response for that mode and exhibits the largest response and adds it to my RSS response. But definitely, I would start out with the square root sum of squares. Or I'm sorry, the absolute sum. It's a more conservative technique. And then do some research and then pick one that's more adequate that will converge a little quicker for you. So that's what's new in dynamic studies with Simulation 2011. All right, let's talk about the interface. Let's talk about simulation interface. So we got some great things happening in this release. The one I was pretty excited about first was the ability to organize your solid bodies in folders. Yes, my friends, so now we are able to do this. This was a pain in the neck. If I wanted to apply a condition or pick different components, I would have to go in and do control select, shift select, and I would go in and then choose a force, or I would choose a property to apply to all these fixtures. Now I can go in and I can right click on any one of these solid bodies and I can say add to new folder, and now I can have a folder in there. I can click and drag additional solid bodies in here, solid entities, and then I can go and apply my forces or any entity or value property to this particular folder. I can dissolve the folder if I like. I can delete that. I can reorganize. It's a great tool. It's something that we use in SOLIDWORKS quite often, so if you're familiar with that, same functionality ported into Simulation 2011. Actually, something that's real nice about this, let me go in and show, where are we? Yeah, let me show another model of this. I have a weldment here, and we have Cutlists and Weldments. Now, in my study, I also have the ability to bring in that cut list into my study. If I open up the study here, expand, so there's my organization brought in just from my SOLIDWORKS. So what's nice is you can drag existing pressure loads to a subfolder under the external loads folder, and or any other attribute. This way you can mass select and set up your studies a little bit quicker. Something else that's new with the simulation is this little filter deal here. This works just like it does inside of SolidWorks. We have the filter. Now we also have it in simulation. So if I want to look for a particular part, I can type in, let's say, structure 2. I can type whatever I'd like in there, and it's going to go in and it will filter those particular models. I can go in and I can choose filter graphics view. Actually, let me show you that with an assembly here. It's a little easier to see. I go to the study. I can go to my filter there, and I can type in, let's say, PC board. And now I can filter the graphics view, and I can only see that filter. Also, another interface change, which I'm pretty happy about, is the ability when we exclude parts from my analysis. If I go into my parts folder and I right-click over a solid body, I say exclude from analysis. When I do that, you'll notice now that we actually hide the particular component we're excluding. We no longer have to do this manually. So it's a great improvement. I'm really happy they put this in. So we can show and hide each individual component as we exclude or include in the analysis. Also, what are some other things that we, let's see, what else can we show? Or any questions? Let me open it up to questions here so far. Another thing that I want to mention here with our interface is that when you change a body's material in a simulation study, if I right-click it and change that up, what's nice, it'll now change the material's appearance, and it'll update that in our graphics area while we're working in the study. So we no longer are a slave to just SOLIDWORKS. The simulation tool will override that as we're working inside of our study when we're updating materials, so we can also see the change graphically in real time. Another thing I want to show is the ability of displaying simulation symbols. That's something new in simulation. Let me open up my other model for that. So let's say I have my study open. Let me go and show some of these forces. Let's say I have this force there, and let's say I have a couple of more constraints on this thing, but I can easily turn on and turn off all of these symbols. If you recall, if I go in and I fix geometry, I apply pressure loads, we get all of this, all of these particular graphics symbols that show up, and it can be daunting to take a look at our actual original geometries if we have all the symbols, all these symbols on our model cluttering everything. So I can easily shut off or turn on all of my symbols related to simulation. I can do this in two ways. I can go up to the View menu, Flyout, go down to Simulation Symbols, and we'll get rid of all my symbols. I can also do this from my heads-up toolbar. If I go up to the View Flyout, there's a little icon with a little simulation box and an arrow, and I can click on that as well to bring it back. Great little improvement. It's a little subtle improvement as well. Let's talk about shells. Some new functionality with shells. Let me open up another example for that. So with shells, I have the ability to offset shells. If you recall, last release, we had the ability to define shells by surface, which was reintroduced. It was removed a couple years ago in 2009, and we were in the community. We were pretty ticked off. We were pretty sad to see that go. They brought it back in 2010, and now they've enhanced it with the ability to offset shells in our studies on the fly. great improvement. Let's go in and show that. Let me open up this study, and I have a shell defined here, and if I go in and I edit that definition, if you scroll down here, I have an offset flyout. I will talk about this in a little bit, but I just want to point out that we have the ability to offset. I can go mid-plane on either side of the selected surfaces. In this case, in my model, I've selected all 6 sides of this hexagonal part. Also, I can do an offset away from my selected surfaces as well. So that's new in 2011 as far as offsets for shells. Something else is in regards to composites. This is great. We were able to do composites last year, but we weren't able to go in and change up the orientation of the plies. So this is an enhancement, is the way we do orientation now in 2011. I can go in and specify the number of plies for my composite. I can choose sandwich or not, choose my units, and this is the great thing about it. I can choose each individual row, and I can see my orientation. So my ply 1 orientation is such that it's 90 degrees for my reference. I've selected row 2, and this will alternate that. That's 0 degrees. And then I have ply 3, which is at negative 45 degrees. So I can go in and I can layer my my different plies on my composite at any angle I want now. Great little improvement, subtle but really powerful. Let's continue on. I want to talk about beams. This is real great. Whenever I teach my simulation courses, I always get asked this question. I get asked, Enrique, what can we go in and can we add on a beam? Can we add a force of 10 newtons on one side of the beam and 20 newtons on the other side? And my answer up until this point was no. Unfortunately, it's a limitation. We'd have to do just some workarounds in order to get that functionality to work easily, or just with a one-click deal. So in 2011, we can do that finally out of the box without having to employ some basic workarounds. We can now take beams and we can have non-uniform and partial loading on beams. It's a beautiful thing. Let me show you this. Let me go in and open up a study here. If we take a look here, I have a force on this particular weldment, and I've applied a force. All I did was just apply a new force. Let me go and edit that. So I'll go in and specify beams for my filter. I've chosen that particular beam. I've chosen a direction. And now I have non-uniform displacements here. It's a great thing. I can go in and I can do a linear magnitude for my force, starting from 0 to a maximum magnitude and back down to 0. I can do a parabolic, just non-uniform displacement, or this one I think is elliptical. Yes, it's an elliptical distribution as well. This is for total load distributions. Now this will go in and nicely, gracefully go between the different orders of magnitude amongst the entire beam. We also have different ways of applying these forces. We have this centered load distribution, which will take the majority of the magnitude of the load and then slightly disperse the rest of it amongst the sides. And another type of flavor is we have the table-driven load distribution. So let me click on that just to show you that we can go in and take a look at that. I can do a save to file, or I can load from a file, and this will let us load data from a CSV or a text file. So that's a real nice little improvement we have for non-uniform distribution there. Let's go in and let's talk about tapered beams. Yes, we can now do tapered beams. We can take a geometry such as these two little squared cone shapes. They're lofts, and we can take these, and as long as the solid body, I guess what quantifies this as a tapered beam is that it's gonna be a nice uniform, equal profiled shape that runs along the same axis. In this case, we have this guy here. If I select that solid body, I can right-click now on that, and I can say treat as beam, and sure enough, now I can expand, and that particular solid body is a beam. Also, I've taken this other loft and I've slightly twisted that a bit, and we can also treat this as a beam, believe it or not. It's kind of cutting it close, but it will accept that as a beam. So whether you want to do that or not, it's up to your assumptions there for your model. The simulation interface will give you a little warning that recommends you to not treat a body as a tapered beam. So you will see that behavior in case you are running a little bit closer than you would like, than the simulation study would like for you to treat certain solid bodies as beams. Something else that's new inside of Weldments for simulation 2011 is the ability to use a European standard for edge welds. This was added. Let me go into my connections folder. There it is. Don't know what happened there. Edge weld. Then I have the American standard, and now I have the European standard, which gives us some abilities to insert certain properties there. So that's something added new to our European friends there. All right. Another thing I want to mention, if you recall, we did when we did contact sets. This is something that we teach in our simulation courses quite often. There's a chapter dedicated to this. Is when I go in and I select my contact sets, I can go in and I choose my different faces that I want to say no penetration to or bonded, and I have an advanced selection here. And now this advanced selection, if you know the behavior of certain entities, you can choose to either node to node, node to surface, or surface to surface contact type. And this will allow us to tell the study to choose a certain portion of its iterative solver. This way it converges a little bit quicker. So we've added something that's new in addition to that in simulation 2011. We have the automatic option for simplified bonding. So if I go out of this, so let's say that I choose a surface-to-surface condition there, and it's taking a little bit longer to converge just because the software detects that there's a node-to-node condition there. It's touching and it's not going to be moving. Then I can go into my study, and I can go to my properties, and under this incompatible bonding options, I have an automatic option now. And this will allow the solver to detect these types of advanced conditions and will allow it to alternate between the three different conditions automatically, causing the solver to converge a little bit quicker, giving you a little more efficiency for your studies. A neat little function there in 2011. All right, so let's talk about mesh. Finally, in 2011, we have the ability to take meshes and we're able to mesh with multi-cores, multi-processors. So thank you, SOLIDWORKS. So again, obviously, what's great about that, we're able to mesh very, very high quality meshes and meshes with a lot of mesh controls and very complex geometries a little bit quicker. So it all depends on what type of architecture you're working with your systems. 64-bit. You have a lot more RAM, so you can definitely load up larger models. So now we can go in and we can mesh these guys a little bit quicker. We're able to have more resources at our disposal for meshing. Also, another thing I want to point out with meshes is we have a default. The default mesher has changed. So let me talk about this. It's nothing to be afraid of. It's actually quite good. If I go into my mesh and I do a create mesh, under mesh parameters, we still have our standard mesh, which is what most of us that are been using the software for a while are used to. It does a standard mesh, and it uniformly applies nodes and creates elements amongst the geometry as it is. Now we were introduced to curvature-based mesh a couple of releases ago, and this allowed us to have the solver go in, or the mesher detect areas where edges change in slope quickly, and the geometry changes a little bit quicker, and it applies a type of automatic mesh control amongst these geometries. Well, in 2011 now, this is the default option for meshing. So if you don't pay attention and you go in and you say standard mesh, create a mesh, it's going to always choose curvature-based mesh, which is not necessarily a bad thing. If you're doing prismatic parts, then you won't have to worry about it. If your parts are nice and blocky, the curvature-based mesh will see that there's no curvature, so you'll be good to go. If your models are very curvilinear, organically shaped, then this will be to your advantage. Also, what's new about curvature-based mesh is under advanced options, we have the ability to remesh failed parts with incompatible mesh. Great little tool that wasn't in there before, so that kind of hindered me from not using this option too much in an earlier release. I usually chose standard meshes. This way, if my mesher said, oh man, this geometry is too hard, I'm going to fail mesh, if I was gone, I could select the remesh failed parts with an incompatible mesh. This way the mesher can change its mode and still mesh successfully. So that option is now available for a curvature-based mesh. Let me talk about, let's see, what else about meshes, anything else that I can think of? Oh yes, one more thing I want to talk about when it comes to mesh, and this is related to beam elements. So if I take a, actually I already did this here on this study, let me show you. If you do a mesh control on a particular beam, if I just, let me just show this particular control, let me edit the mesh control. If I choose a beam structure and I choose a structure, as you see there, I now have the ability to apply a mesh control, and I can select the number of elements that lies across lengthwise for that particular beam. So that's something that was added in 2011, and it gives us a little more control for our models. Okay, just another thing I want to mention. I just want to mention that there's nothing to show for this. Is there's actually some an accuracy up, or there's been improved accuracy for nonlinear fixtures inside of our simulation premium installs for 2011. The way we had these fixtures was an exact method rather than we had an approximate penalty method before. Let me see. Here, let me just read this here, just from my notes here. It's just so we can get you some information on it. It says an exact method rather than an approximate penalty method is used to apply fixtures in nonlinear studies. The new method avoids numerical convergence difficulties encountered by penalty method and improves accuracy and speed for most nonlinear studies. The performance improvement is more prominent, up to 20% gain is what it says here, in analysis time for nonlinear studies with many restraint definitions and higher mesh densities. So this is good news for us, but SOLIDWORKS always tries to improve and gives us better performance. So they're actually saying this here as a specific entity inside of our hit list. So hopefully we'll see some great improvement. Looking forward to that. Also, let's talk about results. Nonlinear plots. You can now plot elemental or principal stresses for your nonlinear plots. So just the way you would do that, you would just right-click and edit definition. You would be able to see and select the first, second, or third principal strain inside of our components. I think I said stress there by accident. Excuse me. It's strain, principal strains. All right. Also, another thing I do want to show you is I have a study here, a thermal study. I want to show you the ability of showing heat power and heat energy in real quickly inside of a thermal study. Let me open up an example I have here. So I have this model, and let me get my study open, and I have hence solve this particular model with I did a transient analysis and just a couple of other studies just to play around with it with 2011. What's good to show and worth noting with thermal studies is I can go in and I can right-click on the results folder, and I can go in and I can show heat power or energy right off the back here. I can choose heat power, and I can choose maybe a face, maybe this particular face, hit update. It's going to give me some information. Now you may notice here we have, for our options, we have heat power and heat energy. With a transient analysis given a certain time domain like I have set up here in this study, we have the ability to choose energy. However, if I have a study that is at steady state, such as this guy here, if I go in and I want to do a heat power, we won't have the ability to do heat energy. Just only heat power. Just want to point that out in case you do run into that later on. Just make a note that heat energy is only specific for transient analyses. Also, this is a good time to show that symbols, if I can remove all of these conditions, I can hide all simulation symbols easily again, just to show that again. And I really like that. There it is. It's gone. I don't have to worry about hiding individual things from the tree and remembering what I've hidden. I can hide or show at will. It's a great little tool. Just things I want to mention here is if I select maybe resultant forces, or if I list forces in my interfaces, I can click on, like, let's say I have a table open and I pick a certain row. That will actually highlight now in 2011. So it gives us the similar functionality you see here when I click on certain things, you get highlighted entities. Same thing happens when I look at pop-ups in Windows with 2011. For example, like list forces is one that I can think of off the top of my head. Just want to point that out just to talk about it. Some more things I want to mention with this thermal study while I have it open is probes. If I go in and I probe this thermal study, and I go to probe, let's say I click on this particular location, we are now able to click and drag my tag away. This wasn't the case until recently, to be able to move that around. It's quite convenient. It gets things out of the way easily. And also we have the ability to hide certain pieces of information from the probe call out there. So notice I removed everything. It brought me back to a default position. But I can just simply show show my value and be done with it. And that's all I really care about. This way I can take a screenshot and I won't have any information that's not pertinent to what the scope of that image is for. So that's what's new with probes. You can move those around. It's real nice. Let's talk about oh yes, sensors. Sensors, we have the ability to find sensors to track the results of nonlinear drop test, linear dynamics, and transient thermal studies now. It's great. I can define these sensors just as before from my right-click menu. Let me get out of here. And if I right-click over the Sensors folder, I can select Add Sensor. I'll select my simulation data. And I want to go in, stress is fine. I want to choose my step criterion here. I can select actually 3 different options. I can select across all steps there. This tracks the simulation data value across all steps for the entire model for the selected entities and reports it as a single value there. Also, I can do a specific plot. And the one that's not shown here is actually for only frequency studies and buckling studies. It's another option that says a specific mode shape, which for obvious reasons is only for frequency style or buckling style studies. And this option will only show that particular mode shape and look at that sensor. Real good stuff. So now we can go in and we can take sensors for these transient studies. All right, lastly with simulation, I want to talk about study reports. So as we're always doing documentation, paper trails are very important. SOLIDWORKS kind of stepped up a little bit here, a little further, and they enhanced the way we approach the study report generation. So if I have this particular model and I want to generate a report, just go to Simulation Reports just as before. But the difference is when I get this to pop up here, I have a little slightly different interface, and there's actually different formats depending on what study you're working with. This way it's not all just homogeneous. You know, you get the same looking result. You have to go in and modify, say, non-applicable, that kind of thing. Now I have certain formats per different study. In this case, I'm using the thermal study format. I can choose to include or exclude any section inside of my report. My report path, I can change that up now. And let me just publish. Let's take a look at what this looks like. It's real nice. They've taken, I guess, ever since they did the, they've been working with 3D via Composer, and we've been doing some more OLE object research. We've gotten a little better at making our reports. So I'm really happy with the result here. We're going to show you in a couple of seconds. almost done there. It's going to go in and take screenshots at optimized zooms, zooming into the geometries so we can get nice, good images in our report. I'm a big fan of this new enhancement. There we go. We get a nice little rendering. So make sure if you're going to be doing this, a good tip is to always have real view graphics turned on, so you get a nice little slick-looking image captures. Or else, if you don't, you'll use this through the regular simulation rendering engine, and your pictures won't look so snappy and so slick. But still, real nice table of contents, gives us model information, and at that point you would have the ability to go in and type in during that interface what you'd like. Some good information. Also, I've seen reports show just information with material properties. There's a graph data that shows the stress strain curves for different types of materials. It's a great little enhancement. It's a lot more clean to work with. And I suppose you could always take off some of these watermarks if you're familiar with that. Put in your company logos. But again, just paper trails are huge for just different approval processes, so or design history files. So this will be a good addition to your tool belt there. Oh yes, when it comes to reports, another thing I want to point out is we do have the ability to do Microsoft Word documents for simulation express studies now. So before 2011, you were only limited to the HTML report, which you could save out and was fine for having a free little resource. But now you can do and choose the option for a Microsoft Word document to have a similar functionality like you saw in our full-blown simulation. So that's you might want to tell some of your colleagues that don't have simulation that they can also do that now. Let's go ahead and switch gears. Let's go ahead and talk about motion studies. So there are only a couple of new things that were added, but very, very cool things inside of motion studies. We're going to talk about this new interface, this new interfacing window called the function builder. This is for force and motor functions. We're able to change that up. Also, just some slight user interface changes due to the fact that we have the function builder. Also, we're going to talk about the ability to apply a result plot of reflected load inertia and reflected load mass. We have that ability as well. Let me just open up a model here, and let's talk about this function builder. So we have this simple model, and I have my motion study interface below. So I've made a simple little motion study here. Let me play that animation. So now we have the ability of going in and applying forces, correct? We can do gravity, forces, motors, a slew of different things that can affect my assemblies in the simulation analysis. Now I do want to point out that if you're going to be using this interface, you do have to have the motion analysis checkbox or selected from my flyout. Make sure you have it selected in your add-ins. If you don't have that, then definitely do a modification of your install or see if you do have a license for motion analysis. So once you have motion analysis turned on, if I want to go in and I want to choose a motor, I can select motor here, and I want to choose from my type of motor, I want to choose a data points. Now this is where my interface has changed to this new function builder window that pops up. So we can go in and we could select data points, and I can choose to import data. Maybe from this, I have a CSV of this that I was using to bring some data information. Real good stuff. I can change my style here. I can do a linear or 3 different options. So this is my function builder. Also, we have the ability just to go in and select expressions. So I can type in an expression, and that can be the way that my motor gets governed. Also segments here, I can choose this interface as well. So this is the function builder in motors. This is also the function for forces. So if I go in and let me show that. Let's type in, where are my forces? If I open forces, and now for my force function, if I change that from constant to data points, I also get the function builder to show up as well. So this is the other area where we've made an enhancement in Motion Studies 2011. So just like, again, I want to point out that some of these function builder options that you see here amongst segments, data points, and expressions are not available for just the regular animation or basic motion study types. I haven't actually gone in and seen some of them. I've only seen a couple I noticed that weren't in there just because the functionality does not apply to anything else but a motion analysis study. Just because of this new function builder, we do have some changes in our interface there. So the interpolated force or motor type is now under the data points, which you saw. So that's just again to point that out under force function. That's the interpolation type is going to be here. So we no longer have that that separate dedicated interface. Also the data. Let's see. Oh yes, just obviously you saw the data points or the data points will launch up this function builder, and so that's basically it as far as any user interface enhancements or changes done in motion studies is due to this function builder. Another thing that I want to point out, which is great, is the ability to create a result plot with reflected load inertias or a reflected load mass. This is something that was added in this release. If I go in and I choose my results and plots icon, I'm going to go under results, and then for my category I'm going to choose other quantities. For my subcategory I'm going to go in and choose either reflected load mass or reflected load inertia. And actually once I've done that, it'll open up my plot, which I've done down here as well. Let me just show that. Show my plot. So there's my my load inertia plot, and I can also do this with a load mass with a just an adequate example. So that's what's new with these results and plots functionalities in simulation motion studies. Lastly, I just want to mention we have the ability to do motion along a path now. For motion analysis studies, we can define a path mate motor and specify displacement, velocity, or acceleration values as the body moves along the path. So that's just you'll just make up a study for that, and you can choose that option now in your motion studies. So that's what I have for us this morning when it comes to simulation. What's new? Does anyone have any questions here? Let me see. I haven't seen any questions show up as of yet, but I'll go ahead and leave this open for a couple minutes here. And yeah, thank you for your time this morning for our webcasts. Let me give you a schedule here of other webcasts we have available coming up. So we have a Enterprise PDM and Design Checker webcast on February 23rd. Not too far along, we have a CircuitWorks and Routing webcast March 9th, and a PhotoView 360 What's New webcast March 23rd. So again, as always, we always have weekly webcasts, so keep an eye out on ddicad.com. Be sure to just subscribe to these webcasts. We really enjoy presenting for you guys, so thanks for taking the time this morning and spending it with us here at DDI. Again, if you have any other, just take a look at some of our other resources for learning about SOLIDWORKS. We have our under our webcast, under services, we have e-support for those of you under subscription for any types of issues you may want to contact our technical support team. We have a nicely dedicated team here at DDI for SOLIDWORKS simulation and other products, so don't hesitate to contact us that way. If you want tech tips or webcasts, be sure to visit our website. So again, thank you for joining us. You guys have a good one.